Today, we're diving into a question that's, well, huge. What makes a child who they are? We're going to unpack the science of child development, and trust me, the answer is way more complex and way more interesting than you might think. Let's jump in.
So, just for a second, what's your gut answer? What makes a kid a kid? We hear nature versus nurture thrown around all the time, right? But as you're about to see, that's not even half the story. The real picture is so much more connected.
Okay, the first big idea we really need to get our heads around is that a child isn't born with their destiny all mapped out. From day one, they're built to adapt. And this brings us to a powerful concept called plasticity. Plasticity is just the scientific term for our amazing capacity to change. It means our brains, our behaviors, our very characteristics, they're not set in stone. They're malleable. They can be molded and reshaped by our experiences throughout our lives. And this is where we totally leave that old nature versus nurture debate in the dust. You see, development is multi-contextual. It's not one or the other. It's a constant dance between our genes, our nature, and our world, our nurture. Our DNA might sketch out the possibilities, but it's our environment that helps color them in. So if a child's environment is so important, how do we even begin to make sense of it all? It sounds complicated, right? Well, a researcher named Bronfenbrenner gave us this brilliant map that shows how a child sits at the center of all these expanding layers of influence. And here it is. This model just lays it all out so clearly. You start with a child, right in the middle. Then you move out to their microsystem. That's their immediate world, like family and school. But then it gets bigger. You've got the exosystem, things that affect them indirectly, like a parent's job. And all the way out, you have the macrosystem, the culture they grow up in. Even the period of history they're born into, the Chronosystem, plays a part. The whole point is you can't understand the kid without understanding their entire interconnected world. Okay, this framework is fantastic. It makes so much sense. But, and this is a big but, how do we actually know any of this is true? How do scientists figure this stuff out without just making up good stories?
Well, the reason we need science is that our own intuition, as powerful as it feels, can be incredibly tricky. It can mislead us. In fact, let me show you exactly what I mean.
I want you to do something for me. Just read the phrase on the screen out loud. Go for it. Paris in the spring. Simple enough, right? So did you notice anything weird? A lot of people, most people actually, don't. Their brain just skips right over that second the. Why? Because your brain is a pattern-matching machine. It's seen Paris in the spring so many times, it just fills in what it expects to see, not what's actually there. That little trick is a perfect example of something called confirmation bias. It's this natural human tendency to look for and see things that already confirm what we believe to be true. And you can see how this could be a problem, right? It can affect everything from parenting advice to big educational policies. That's exactly why we need objective science to cut through our biases. All right, let's look at another classic mental trap that science helps us sidestep. And for this one, we've got a bit of a mystery on our hands, and it involves ice cream. So here's a totally true fact for you. If you look at the data, you'll see that when ice cream sales go up, so does the crime rate. So what's going on? Does eating a scoop of Rocky Road make you want to go out and break the law? Probably not, right? And look, the chart doesn't lie. When one goes up, the other goes up. They move together. This is what's known as a correlation. Now, a correlation just means two things are happening in a similar pattern. But, and you should tattoo this on your brain, correlation does not equal causation. Just because two things happen together, it doesn't mean one is causing the other. So many bad ideas and fads are built on this simple mistake. So, what's the real story with the ice cream and crime? There's a hidden player, a third factor we weren't looking at. The real culprit is temperature. When it gets hot, people buy more ice cream. And when it gets hot, more people are outside, which, unfortunately, leads to a rise in crime. Temperature is the confounding variable that connects them both. So, we've established that our intuition can play tricks on us, and that just because two things are connected doesn't mean we know why. So what's in the toolkit for a real developmental scientist? How do they get to the truth? Well, here are two of the biggest tools. On one side, you have observational studies. That's where scientists just go out and watch people in their natural environment, like a playground. It's awesome for seeing how people really behave. The only problem? You can't say for sure why they're doing what they're doing. To figure out the why, you need an experiment. In a controlled lab, you can isolate variables and pinpoint cause and effect. The trade-off, of course, is that a sterile lab isn't always the same as the messy real world.
So let's put it all together. To really truly understand a child, you need both pieces of the puzzle. You need that big picture framework like Bronfenbrenner's to see their whole expanding universe, and you need the sharp, precise tools of science to make sure the conclusions you're drawing about that universe are actually right.
And that really leaves us with one last big question to chew on. If every single child's world is this beautifully complex, this layered, then what does that mean for us? For parents, for teachers, for society? How can we best help them navigate it all and build environments where they can truly thrive? That's a question we're thinking about.